We've established that blockchains are decentralized record-keeping containers. In a traditional database, a single administrator is in charge of approving and processing changes to the underlying records. In a blockchain, the network as a group replaces this single gatekeeper. Let's take a look at how records are stored and added to the blockchain. Records are stored in a distributed way. Each holder of a registered copy of a blockchain is called a node. Nodes have full access to the data in the blockchain and maintain their own copy on their own devices. Say that the members of the town are all nodes, including Morgan, Jay, Mike, and Deb. Any one of them can propose adding data to the blockchain in the form of a new block. Say Morgan buys a plot from Mike. To record this change in ownership, she adds a block to her version of the blockchain. So then what happens? Well, nothing, unless the majority of the nodes agree to this block and the underlying data. If they don't agree, they will simply not replicate Morgan's changes on their own versions, thereby rejecting the proposed block. When the network as a group approves a new block, individual nodes will update their own copies, effectively syncing with the latest source of truth. To better understand how this works in practice, imagine you want to pay a friend 1 Bitcoin, the cryptocurrency encoded by the Bitcoin blockchain. This payment eventually will be recorded in a new block on the chain, batched together with 1,000 to 2,000 other transactions. Before the network can decide to add or reject the block, they need to be sure it is valid, meaning the data is true and consistent with the rest of the chain. In this case, do you have enough Bitcoin to actually make this payment? Are you who you say you are? Information about your attempted payment is instantly shared across the network, and your transaction joins a pool of other unconfirmed transactions. Nodes in the network will work through this pool, validating your and other transactions by working through the cross-checks established by the blockchain protocol. For example, on the Bitcoin blockchain, one piece of the validation step is ensuring that the transaction is approved by both you and your friend. This is done via a digital signature process that requires a valid private key which is unique to every person and invisible to others. The network can confirm if a transaction is approved with a specific private key without seeing the key. This signature ensures that only you can transact with your Bitcoin. Any of the nodes can chip in to help review and validate transactions. Sometimes, however, more hands make more problems. Consider that as the network grows, more transactions are being added and more nodes are involved in validation. Imagine being in an increasingly crowded auction hall where everyone is independently trying to buy and sell the same goods. Some control is required. For example, how can the network avoid simultaneously processing conflicting transactions or transactions that are double spending the same Bitcoin? Blockchains like Bitcoin must establish a protocol called a consensus mechanism for clarifying roles in validation. This is like assigning an auctioneer. This is effectively a way to force the network's attention to one block at a time. Bitcoin uses a consensus mechanism called proof of work, which focuses the network's attention by selecting a single node to propose each new block. The selection is done via a puzzle. Whoever solves the puzzle gets to add the next block. Sounds fun, right? The puzzle, a built-in cryptographic algorithm, converts input numbers into unique output numbers. The only way to find the winning output number is to input random guesses. This is like a really difficult dice game. Imagine rolling a set of 1,000 dice until you get 1,000 sixes. Puzzle solvers will attempt trial after trial. This is called Bitcoin mining. Once a winning number is found, the miner will verify the transaction details and then propose a new block. Nodes, seeing that a winner has been found, will pause what they are doing to confirm the newly proposed block. If the majority of the nodes agree that the winning number and transaction details are all valid, the block will be added. The successful miner is rewarded with Bitcoin currency, BTC. Proof of work is a resource-intensive process. Bitcoin miners are running high-powered computers 24/7 all around the world. In 2021, Bitcoin miners used as much energy as the entire country of Argentina. Another limitation is that miners are increasingly joining together in mining pools to increase their odds of success. This is perversely incentivizing consolidation rather than the decentralization of the network. Currently, the top 3 pools collectively own more than 50% of the nodes. Proof of stake, an alternative approach, uses a lottery rather than a puzzle to appoint the winning node, who will be given a cryptocurrency reward. To be selected in this lottery, nodes buy stake in the network. Buying more stake is like buying more lottery tickets. It increases your odds of being selected. Since no puzzle solving is required, this is a faster and less resource-intensive method. And for that reason, the Ethereum blockchain is currently transitioning to proof of stake from proof of work, a process widely known as the merge. Bitcoin was built with the goal of creating a digital currency. Issuing and transferring Bitcoin was in fact its purpose. Other blockchains that have emerged since, like Ethereum, were built with different purposes in mind. For example, to encode information about non-financial transactions. Remember, the blockchain is a container that can record any type of digital information. These other blockchains also require nodes to actively participate in the addition of new data, as in the case of proof of work or stake. This participation requires compensation, which most blockchains offer in the form of their own token. This is the cryptocurrency. The Bitcoin blockchain issues the cryptocurrency Bitcoin, or BTC. Ethereum issues Ether, or ETH. And other chains issue their own currencies. This explains in part why we see so many cryptocurrencies. With more and more applications for blockchain, more new chains are constantly emerging, and with them, more cryptocurrencies.